Good evening, all. Welcome to the pantechelearning project webinar series. Today, we are going to see the project number 11, which is wireless communication system domain. Okay. We will like to thank to the IETE, the Indian Institute of Electronics and Telecommunication Engineering, who is supporting to conduct this webinar series. Today, our project title is Group Mobility by Cooperative Communications for High-Speed Railway Systems. Okay. So here we have selected the group mobility by cooperative communication for high-speed railway title because with a rapid development of high-speed railway technology, its velocity we important part of the high-speed railway system is handover. Okay, so here the major considerations we are going to see the handover technique with the help of the cooperative communications. So cooperative communication is nothing but with some relays we are going to make the signals passing from the base station to the user. Okay. There is a two type of communications, non-cooperative and cooperative communications. Today in this webinar we are going to see what is the difference for the cooperative and non-cooperative communications. Also we are going to see how the cooperative communications we can able to achieve the high signal strength with the help of relays technique. It will be useful for the high speed railway communications. Okay. Okay. For that, today the IEEE paper I had taken for the performance analysis of high speed railway handover scheme with different network architecture. In this paper, they have clearly given what all the techniques followed in the previous method. Okay. What is the performance of that previous method, what all the techniques they have followed, like that they have given in this paper. So we are going to analyze this paper for our proposed system. Okay. 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 In this paper, they have considered one triggered method handover problems. Okay. They have used one like a triggered method to avoid the handover technique. But in our proposed system, we are going to use the relay methods. Okay. With the relays, how can we avoid the handover problem? Okay. That is our project title. So the main objective is to solve the individual handover problem by using moving relays by through the cooperative communications. We are going to analyze with the help of the relays different types of relays. How much of one relay can give the throughput? How much two relays and how much four relays can give the throughput? Okay, like that we are going to see. Okay. Before we must know what is the difference between the cooperative communications and non-cooperative communications. Non-cooperative is nothing like a direct communications between the base station and the user. Okay, there is no any relays or trigger method they have used. Only the signal from the base station to the user we will get. Okay, the type of communication is the direct communications. The direct communication indicates the non-cooperative communications, without any antennas or arrays or cells. There is a direct link between the base station. The signals will pass transmit from the base station to the user. So that is non-cooperative communications. But here we are going to consider the cooperative communications. Okay. So why we are using in the sense, basically, if without a relays and without any trigger method in the sense, there will be some handover problems will be occur. Handover occurs due to okay in in this scenario, like this is one sector and this is another sector. Okay, for one sector will be a one base station will be there, and another sector will be another base station. So when the train moving from the one base station to the another base station, in the sense, immediate handover is required at the so then only we can able to communicate continuously, or otherwise there will be a call drop or interrupt occurs. Okay, so in direct communication, the handover will not get at the time. Okay, when the train reach at the edge, in the sense, it can't able to get the signal from the next nearby base station. So this all the one of the problem while in the non cooperative communications. Okay. Okay. Why it occurs like handover problems, in the sense, due to the high mobility of the high speed railway. Okay, it brings problems such as a signal instability and frequent switching to the high speed railway handovers. It requires frequent handover in if it is not movable, in the sense, we can able to get the handover at the time, but in moving high speed, in the sense, the handover is one of the major problem. So in existing method, we have faced in the frequent handover problem is not achieved in the existing method. Okay, this often lead to intermittent interruptions of the communications, and it will result to the sharp drop in the communication qualities. So these are the disadvantage over the existing one. Okay, so it will not suitable for the high speed mobility vehicle, that is non cooperative communication. It will not suitable for the high speed. Okay, that is when the train moving from one sector to another sector, in the sense, it can't able to get the handover at the time. Okay, so we have moved to the relay system. Okay, relays or triggered method. In this paper they have explained the triggered method with the different types of antennas they have used. Okay, here different types of antennas they have used to avoid the handover problem. Okay, but this will be the implementation cost will be high for this type of technique. Okay, um, even though it achieved the handover problems, but it it is the cost of the implementations will get high under this type of techniques. Okay, here in this paper they have used a different types of antennas. Okay, DAS scenarios, that is they used different antennas to avoid the handover techniques. So what will happen when even though the base station can't give the signals, in the sense, these antennas will can able to provide the signals at the time when the train moving from one sector to the another sectors. Okay. Okay. For the literature survey, I have taken what will happen for the single antennas. Okay, in this paper, the an optimized handover trigger scheme in LET system for high speed railway, they have used a single antenna for in the train. Okay, single antenna in the train, in the sense, like in this way. Okay, they have placed one single antenna on the train, uh, or relay on the train. Okay, single antenna relay on the train to avoid the interruptions. Okay, single antenna and dual antenna. Okay, and then multiple antennas like that they have used. But in our proposed system we are going to use relays, two relays how much, four relays how much, like that we are going to see. Okay, so single antenna, whenever we are using a single antenna handover scheme, it require it reached the problem called the we can't able to get the quality of service. Okay, even though in the single antenna scheme. Okay, and second, two antennas. Okay, two antennas in the sense, in the front end and the back end. Okay, they have fixed two antennas from the front end and the back end. Okay, the front end will act as a handover scheme, and the back end will frequently give the signals to the users. Okay, it will get the signals from the base station, and it will give to the users frequently. So two antenna scheme also they have used. uh, but in this scheme cannot perform handover in a suitable handover opportunities under such low signal strength. Whenever if the low signal strength occurs, it will not support to the provide the full strength of signals. Okay, so these methods also will get one of the drawbacks. Okay, and then they have used the switching scheme under the distributed antenna system. This is the like a distributed antenna scheme. Okay, they have used a switching scheme. If one antenna can't able to give the signal strength, in the sense it will trigger the next antenna, and the next antenna will give the signals to frequently, like that they have used the switching scheme. Okay, so in this method, they have used based on the switching scheme under the distributed antenna system. It will provide a frequent handover to the train. Okay, but the cost of implementations will get high under this type of systems. Okay. So, okay, what we are going to do in the proposed system, in the sense, we are going to use the relays method. In non-cooperative communications they have used without relays, but here we are going to use the relay techniques. Okay, relay in the sense, we are going to place four relays to get high quality of signals, and to avoid the handover problem. Okay, this is the proposed system. uh, Here we are going to use one moving relay, and the okay, whenever the base station can't able to give signals to the dead zone, that time this relay will support to give the signals to the uh, in the death areas. Okay, so this that that zone like cell edge or shadows areas. For these areas, the relay can able to give the signals. Okay. Okay, what are the advantage of the relays we having? Because of it has a low deployment cost. When when the relay which is used, if you are using relays, in the sense the cost for deployment will get low. Okay, and also we can able to deploy anywhere. um, okay, and it can also perform well in the non-line of sight. Okay, line of sight is occur because due to the obstacles and penetrations, due to the from the tree and buildings everything. Okay, so it can perform well in the non line of sight. Okay, whenever the obstacle is there in the sense, that time also this relay can able to give the signals. Okay, and then low power consumption device, it requires only a low power consumptions. It doesn't require high power uh, to generate. Okay, it requires only a low power. And then moving towards communications, and relay can perform well in shadowing. That means at the dead zone also it can able to provide signals to the users. So these are the advantage of the relay. That's only we are going to move with the relay concepts. Okay. Okay. So the next one is the performance parameters. What are the things we are going to analyze in this project? Okay. What are the things in the sense signal to noise ratio? With signal to noise ratio, that is how much of signal strength we are getting with the help of the relays. Okay, and then outage probability. Okay, how much of can these types of relay technology will give the um, throughput, like that. Okay, coverage probabilities, the transmissions, how much of transmissions capacity it can give, whether by using how much distance it can able to sustain, like that we are going to analyze. And finally we are going to see the difference between the non cooperative and the cooperative communications. That means with relay and without relay, what is the parameters, what is the SNR, what is the capacity we can get with the with relays and without relays. Okay. Okay, for SNR, as I told, signal to noise ratio, that means how much of signal strength, like um, the total number of signals, the received signals with the total number of noise, that will be denoted as the SNR. That means like um, here signal to noise ratio, which is the ratio of a received signal power to the sum of the noise, how much of noise added to the original signals, that we have to calculate with the SNR. This SNR is the most important parameter to measure the performance of any communication system. Okay, like it is the nothing but it is the ratio of the received signal power, how much of signals we are receiving at the end to the total number of some of the noise. Normally when we pass the signals from the base station to the user in the channel, there is a chance of adding the noise into the signals. So we must have to analyze how much of noise added in that signals, and how much of interference power signals is there. So here we are going to calculate the SNR with the relays. Okay, so these formulas I have taken from the previous paper. Okay, here they have used for the one relay and two relays. Okay, what is the um, SNR ratio for the two relays and one relay? For the one relay, they define the formulas here. Here G denotes the gain and power and the distance between the relay and the base stations. Like that they have mentioned. So here they have given for one relay and two relays. So, okay. So by these formulas, we are going to modify for the four relays. And next one is transmission capacity. And the transmission capacity is the successful number of transmissions per unit area. How much of transmissions occur in per unit area? That means a base station, how much of the users under the base station can able to get the signals. Like that, we are the transmission capacity will analyze. The large transmission capacity means the more efficient model of the transmissions. Okay, here we are going to analyze the transmission capacity for cooperative and non-cooperative. The four moving relays have a greater transmission capacity as compared to the one moving relay and two moving relay. Okay, which is due to the more coverage area. So with the help of this transmission capacity, we can analyze how much of coverage area can able to cover produce with the help of the four moving relays. Okay, so the cooperative communications with two moving relays, like a four moving relays, enhance the transmission capacity. Okay, let's see how much of transmission capacity can achieve with the help of the four moving relay. This is one of the parameters we are going to analyze. Okay. And next one is coverage probability. Coverage probability is the a cumulative distributive function of the SNR. With the help of this SNR, we can calculate the probability of coverage. Probability in the sense how much of can the user can able to get the signals. Like that, we are going like with the help of the SNR, we are going to calculate the CDF. Okay, the coverage probability, that is the probability of the user can able to cover with the with the help of the SNR. Okay, here we are going to take the threshold. Threshold is nothing but a minimum values required to stand the power. Okay. So in this project, we are going to analyze the SNR first. Okay. Okay, the first parameter is signal to noise ratio. For that, I have take separately. Okay, uh, here we are going to calculate for two relays. The parameters and all we are going to take how much of bits we are going to transmit. Okay, how much of iterations we are going to pass it, and the transmitter ray and the receiver relays. Okay, then this result will I'm going to save in one file. Okay, this snr for the two relays will be saved, and for all the relays, two relays and three relays and also we are going to calculate separately the snr. Finally we are going to compare it. Okay, finally after we are going to load every result for the relays. With the help of this we are going to plot it and compare with the non-cooperative. Okay, like that separately we have to calculate for the snr for the non-cooperative and the cooperative with a relay 1, relay 2 and relay 4. Okay, so here. Okay, here this is the SNR plot for the different types of relay 1 and relay 2, relay 4. Okay, how much of relay 1 is getting signal strength, how much of relay 2 we getting signal strength, how much of relay 4 we are getting signal strength. So by this graph we can able to conclude the signal relay 4 can able to get the high signal strength. Okay, in previous method they have followed relay 1 and relay 2. In proposed method we are going to use relay 4 relays on the top of the train. So that what will happen, with the use of the 4 relays we can avoid the handover problems. Okay, if one relay is not getting handover at the time, in the sense we can the next relay can able to get a handover, so we can able to get high signal strength. Okay, with the help of the relay 4. In this relay 1 and 2, blue and red indicates relay 1 and 2. Relay and 1 and 2 I am getting very low signal strength. Okay, but when I'm using 4 relays I am getting signal strength high. So this is the concept here. Okay, in previous method they have used only 2 relays, but in proposed system with the 4 relays I can achieve the high signal strength. Okay, so the one parameter is signal strength, and another one is transmission capacity. Transmission capacity in the sense how much of transmissions can able to possible with the help of 4 relays, whether it can cover only a small area or it can able to cover large area. Like that we are going to analyze it with the help of the transmission plot. Okay, so okay. Okay. In this transmission, I have considered separately for 2 relays. Same here, we have to calculate the transmission capacity from this formula. Okay, with the help of the signal to noise ratio and the threshold, we are going to calculate the transmission capacity. From this formula, I'm going to consider and apply for different types of relays. Okay, for two relays, I'm going to calculate with the formulas of the transmissions. By applying the formula, I'm going to calculate the transmission capacity for two relays, also for different types of one relay, two relays, and four relays, also for without relays. Okay, and here I am taking the minimum threshold 0. 0.4. Okay, this transmission capacity will be taken for the threshold and the SNR. Okay, with the help of this SNR and the threshold, I'm going to calculate the transmission capacity. That is nothing but how much of transmission can able to possible with the help of a relays. Okay, here the comparison for the 1, 2, 4 and the non-cooperative communications. Okay, let's see the graph. Okay, here without a relay I can achieve a minimum transmission capacity only. Okay, only like for 20, at 20 I am getting only 1.3. That means minimum amount of transmission capacity only I am getting for without relay concept. But when I using the relay one, in the sense it get more it get more transmission capacity comparing with the non-relaying. Okay, and if I increasing the relay, it will, the transmission capacity also increasing. So that is the concept here. Okay, so here I can achieve more amount of transmission capacity without relays. Okay, so this is the result for the transmission capacity. Okay, and same thing we have to calculate for the throughput and CDF. Okay, okay. Okay. The next one is CDF, that is cumulative distributive function of SNR. Okay, with the that is uh, the probability of signals. The coverage probability can be done with the help of the SNR. Okay, so here we are going to find the probabilities. Okay, and the throughput. Okay, here for the non-cooperative, I'm getting low capacity. Okay, like here throughput is nothing but how much of signals can able to receive through the for the like how much of signals can able to achieve. Okay, that is a throughput. Here without relays I'm getting low capacities. Okay, for 25 SNR, at 25 SNR we are getting only 9.4 capacity at the for the non cooperative communications. Okay, while using the corporate like relays, I'm getting increasing, it's frequently increasing. For the four relays I'm getting high uh, capacities. Okay, so here um, with the help of those formulas I have calculated this. And here the result for the non-cooperative: red indicates the non-cooperative, green is one relay, blue two relays, and four relays. Okay, so while I am using the four relay, I can able to achieve the capacities for the high amount of capacities achieved with the help of the four relays. While using one relay, it is nearly close to the non-cooperative without relays. So there is no usage of using a one relay. So if I increasing the relay, one relay at the front end and another relay at the back end, in the sense it will like increasing only little amount. Okay, so if I am using four relays, in the sense I can able to get high capacity. Okay, so this is the concept of four, applying the four relays. Okay, also, okay, here the probabilities of users can achieve cumulative distributions functions denotes the probability, how much of probabilities. Here I'm occurring only low probabilities for the non without relays, in the sense I'm achieving a low, like a 9.2 only I'm achieving. Okay, for four relays I can, the probabilities will get increased, that is chances of users in the channels. Okay, that chance probabilities by the relay 4 get increase. Okay, so here the CDF versus SNR plot. Okay, so this is the concept. That is if we are using four relays, we can able to achieve high transmission capacity and high signal strength and high throughput, and the probabilities of users in the we can achieve more with the help of the relay techniques. Okay, so in this project, how without relays, that is non-cooperative communications and the cooperative communications we have done. Okay, so these are the formulas I have taken in the previous papers. Okay, for the SNR and other okay, and other parameters like coverage probabilities and outage CDF, everything I had taken from the previous paper. Here they have used only two relays. Okay, one and two. So additionally, in our proposed, we are going to use four relays. So four relays, in the sense how much of we are increasing the transmissions capacities and all, we will analyze. Finally, the hand of probabilities increasing as a train goes to the base station boundaries, right? Because the receipt signal reduce the near cell boundaries, and it further decrease the SNR. Due to the reduced SNR, um, here we can the user don't receive the proper signals at the cell boundaries. The user move to the another base station, like according to the protocol, the hand of probability decreasing. Okay, so increasing the number of relays, the hand of probabilities will decreases. That is the concept here. The moving MR reduce the individual handoff and prefer the group handoff. Here we are using the MR, right? So it will amplify and retransmit the signals, which has the advantage to the increasing the presence of high speed railway communications. Okay. Okay, we are doing the projects, training and products. If you want to clarify any projects or training, you just reach us. We having the branches all over there. You can reach any one of the nearby branch. Okay. Um,